Python. Python is a programming language that is widely used for web development, scientific computing, data analysis, artificial intelligence, and more. Python was first released in 1991 by Guido van Rossum, and its design philosophy emphasizes code readability and simplicity. Some of the key features of Python include filled circle. It's simple, easy-to-learn syntax, which makes it a great language for beginners. Filled circle. A large and active community, which has created a wide variety of libraries and frameworks that can be used for a wide range of tasks. Filled circle. Support for multiple programming paradigms, including object-oriented, functional, and imperative programming. Filled circle. Interpreted execution, which makes it easy to test and debug code. Python is often used for filled circle web development, with frameworks such as Django and Flask. Filled circle scientific computing and data analysis, with libraries such as NumPy, Pandas, and Matplotlib. Filled circle machine learning and artificial intelligence, with libraries such as TensorFlow and scikit-learn. Filled circle automation, system administration and scripting. Filled circle building desktop and mobile applications with libraries like Kivy, Pyqt, etc. Python's popularity continues to grow, and it is consistently one of the most popular programming languages in the world. Installing Python. There are several ways to install Python, depending on your operating system and requirements. 1. The easiest way to install Python is to download the official Python installer from the Python website, http URL. This will install the latest version of Python, as well as the IDLE, Integrated Development and Learning Environment, which is an IDE to write Python code. 2. Another way to install Python is to use a package manager like apt, Linux, Brew, Mac, or Choco, Windows, to install Python. #Mac Brew install Python #Ubuntu Linux sudo apt get install Python 3 #Windows Choco install Python 3. You can also install Python using Anaconda, which is a distribution of Python and R. That includes a package manager, an environment manager, and a collection of libraries, modules and packages commonly used in data science and scientific computing. You should make sure to install the version of Python that is compatible with your operating system and the tasks you plan to use it for. After the installation, you can check the version of Python by running the command Python version. Python can also be run using virtual environments, which allows you to isolate different versions and dependencies of Python on a single machine. The tool virtualenv and venv are commonly used to create virtual environments. Most popular Python IDE. There are many integrated development environments, IDEs, that can be used to write and debug Python code. Some of the most popular IDEs are 1. PyCharm. PyCharm is a popular and powerful IDE developed by JetBrains. It has a wide range of features including code analysis, debugging, and testing, as well as integration with version control systems like Git. PyCharm has two versions: Community and Professional Edition. 2. IDLE. IDLE is the default IDE that comes with Python. It is a simple IDE that is suitable for beginners and small projects. It has basic features like code highlighting and debugging. It's part of the Python Standard Library 3. Visual Studio Code, VS Code. VS Code is a popular and versatile code editor developed by Microsoft. It has a large number of plugins for Python development, including support for debugging, linting, and formatting. 4. Jupyter Notebook. Jupyter Notebook is an interactive environment that allows you to write, execute, and document code in a web-based environment. It is widely used in data science, scientific computing, and machine learning. 5. Spider. Spider is an IDE that is specifically designed for scientific computing and data analysis. It has a range of features such as code analysis, debugging, an interactive console all in one place. It comes with Anaconda. These are some of the most popular IDEs for Python, but there are many others, each with its own set of features and strengths. It is worth trying out a few different IDEs to find the one that best suits your needs and preferences. Variables in Python. In Python, a variable is a named location in memory that stores a value. When you create a variable, you can give it any name you want, as long as it follows the naming rules in Python. Here are the rules for naming a variable in Python. Filled circle. A variable name can only contain letters, numbers, and underscores. It cannot contain spaces or special characters. Filled circle. A variable name must start with a letter or an underscore. It cannot start with a number. Filled circle. A variable name is case sensitive, so my variable and my variable are different variables. Here's an example of how to create and use a variable in Python. X equals 10 print x. This code creates a variable called x and assigns it the value 10. Then it prints the value of x to the console. You can also assign a value to a variable and then change its value later in your code. For example, x equals 10 print x. X equals 20 print x. This code will print 10 and then 20 to the console. The value of x is changed from 10 to 20 after it is initially assigned. In Python, you don't need to declare the type of a variable when you create it. The type of a variable is determined automatically based on the value you assign to it. Comments. In Python, a comment is a line of text that is not executed by the Python interpreter. Comments are used to add notes or explanations to your code, and to temporarily disable parts of your code. To add a comment in Python, you use the hash symbol. Anything following the hash symbol on a line is considered a comment, and is ignored by the Python interpreter. Here's an example of a Python comment. Hash. This is a comment. It is not executed by the Python interpreter. X equals 10 hash. This is also a comment. It is ignored by the interpreter. Comments are often used to explain what a piece of code does, or to temporarily disable a piece of code that is causing problems. Hash. This code calculates the average of a list of numbers. Numbers equals 1, 2, 3, 4, 5. Total equals sum, numbers. Average equals total, len, numbers. Print, average. Hash. This code is commented out and will not be executed. Hash. Numbers equals 6, 7, 8, 9, 10. Hash. Total equals sum, numbers. Numbers. Hash. Average equals total, len, numbers. Hash. Print, average. In this example, the first block of code calculates the average of a list of numbers and prints the result to the console. The second block of code is commented out and will not be executed by the Python interpreter. Receiving input in Python. In Python, you can use the input function to receive input from the user. The input function waits for the user to type some input and press the enter key, and then it returns the input as a string. Here's an example of how to use the input function to receive input from the user. Name equals input, enter your name. Print, hello, plus name. This code will prompt the user to enter their name, and then it will print a greeting to the console. For example, if the user enters John, the code will print "Hello, John" to the console. You can also use the input function to receive numeric input from the user. However, the input is always returned as a string. So you will need to cast it to a numeric type, such as an integer or a float, if you want to use it in a numeric context. Age equals input, enter your age. Age equals int, age, hash cast the input to an integer print, your, plus str, age, plus, years old. This code will prompt the user to enter their age, and then it will print a message to the console indicating their age in years. Strings in Python. In Python, a string is a sequence of characters. You can use strings to represent text, store data, and many other things in your Python programs. To create a string in Python, you can use single or double quotes. Here are some examples of creating strings in Python. String 1 equals hello, world. String 2 equals hello, world. You can access individual characters in a string using indexing. The index of the first character in a string is 0, the index of the second character is 1, and so on. Here's an example of how to access characters in a string. String equals hello, world. Print, string, 0, hash output, hprint, string, 1, hash output, eprint, string, 2, hash output. You can also use slicing to access a range of characters in a string. Slicing uses the syntax string, start, end. Where start is the index of the first character to include in the slice and end is the index of the character after the last character to include in the slice. For example, string equals hello, world. Print, string, 2 to 5, hash output, print, string, 5, hash output, hello print, string, 7, hash output, world. There are many other operations you can perform on strings in Python, such as concatenation, joining two strings together, formatting, and searching. You can find more information about working with strings in the Python documentation. Arithmetic operations in Python. In Python, you can use the following arithmetic operators to perform basic math operations. Filled circle plus, addition filled circle, subtraction filled circle asterisk, multiplication filled circle, division filled circle %, modulus, remainder after division. Filled circle asterisk asterisk, exponentiation. Here are some examples of using these operators. X equals 10, Y equals 5 hash addition print, X plus Y, hash output, 15 hash subtraction print, X, Y, hash output, 5 hash multiplication print, X, Y, hash out, 50 hash division print, X, Y, hash output, 2.0 hash modulus print, X% Y, hash output, 0 hash exponentiation print, X asterisk asterisk Y, hash output. 1000. Note that division always returns a float, even if the division results in a whole number. If you want to perform division and always get an integer result, you can use the operator. For example, print 11/3, hash output 3.6665 print 11, 3, hash output 3. You can also use parentheses to specify the order of operations in your calculations. For example, X equals 10, Y equals 5, Z equals 2 print, X plus Y, asterisk Z, hash output 30. In this example, the value of X plus Y is calculated first. And then the result is multiplied by Z. The output is 30. If statements in Python. In Python, you can use an if statement to execute a block of code if a condition is true. The syntax for an if statement is as follows. If condition. Hash code to be executed if the condition is true. Here's an example of an if statement in action. x equals 10 if x greater than 5. Print, x is greater than 5 inches. In this example, the condition is x greater than 5. If the value of x is greater than 5, the code block will be executed. And the message, x is greater than 5 inches, will be printed to the console. If the value of x is less than or equal to 5, the code block will not be executed, and the message will not be printed. You can also use an else statement to specify a block of code to be executed if the condition is false. The syntax for an if-else statement is as follows. If condition. Hash code to be executed if the condition is true.
Treatment. X equals 10. If x greater than 10. Print, x is greater than 10. X. Elif can. Hash code. Elif can. Hash. The syntax for an if-elif-else statement is as follows. If condition 1. Hash code to be executed if condition 1 is true. Elif condition 2. Hash code to be executed if condition 1 is false and condition 2 is true. Elif condition 3. Hash code to be executed if condition 1 and condition 2 are false and condition 3 is true. Else. Hash code to be executed if all conditions are false. Here's an example of an if-elif-else statement. X equals 10. If x greater than 10. Print, x is greater than 10. Elif x equals 10. Print, x is equal to 10. Else. Print, x is less than 10. In this example, the first condition, x greater than 10, is false, so the code block under the if statement is skipped. The second condition, x equals 10, is true, so the code block under the elif statement is executed, and the message, x is equal to 10 inches is printed to the console. The else block is not executed because one of the previous conditions was true. Comparison operations. In Python, you can use comparison operators to compare the value of two variables or expressions. Comparison operators return a Boolean value indicating whether the comparison is true or false. Here are the comparison operators available in Python. Equals, equal to, equals, not equal to, greater than, less than, greater than equals, greater than or equal to, less than equals, less than or equal to. Here are some examples of using comparison operators. X equals 10. Y equals 20. Hash equal to. Print, X equals Y, hash output, false. Hash not equal to. Print, X equals Y, hash output, true. Hash greater than. Print, X greater than Y, hash output, false. Hash less than. Print, X less than Y, hash output, true. Hash greater than or equal to. Print, X greater than equals Y, hash output, false. Hash less than or equal to. Print, X less than equals Y, hash output, true. While loop in Python. In Python, a while loop allows you to execute a block of code repeatedly while a condition is true. The syntax for a while loop is as follows. While condition. Hash code to be executed while the condition is true. Here's an example of a while loop in action. X equals 0. While x less than 5. Print, x. X plus equals 1. This code will print the numbers 0 through 4 to the console. The condition x less than 5 is checked at the start of each iteration of the loop. If the condition is true, the code block is executed, and then the value of x is incremented by 1. The condition is checked again. And the process repeats until the condition becomes false. It's important to make sure that the condition in a while loop will eventually become false, or the loop will run indefinitely. This is called an infinite loop. You can use the break statement to exit a while loop early if a certain condition is met. For example, x equals 0. While true. Print x. X plus equals 1. If x greater than equals 5. Break. In this example, the loop runs indefinitely because the condition is always true. However, the break statement is used to exit the loop when x becomes greater than or equal to 5. This code will print the numbers 0 through 4 to the console. You can also use the continue statement to skip the rest of the current iteration of the loop and move on to the next iteration. For example, x equals 0. While x less than 5. X plus equals 1. If x%2 equals 0. Continue print x. In this example, the continue statement is used to skip the rest of the current iteration if the value of x is even. The output of this code will be the odd numbers 1, 3, and 5. For loops in Python. In Python, a for loop allows you to iterate over a sequence, such as a list, tuple, or string, or other iterable object. The syntax for a for loop is as follows. For item in iterable. Hash code to be executed for each item in the iterable. Here's an example of a for loop that iterates over a list. Fruits equals apple, banana, cherry. For fruit in fruits. Print fruit. This code will print each fruit in the list to the console, 1 per line. You can also use the range function in a for loop to specify the number of iterations. The range function returns a sequence of numbers that you can iterate over. The syntax for using range in a for loop is as follows. For I in range, start, end. Hash code to be executed for each value of I in the range. Here's an example of using range in a for loop. For I in range, 5. Print I. This code will print the numbers 0 through 4 to the console. The range function starts at 0 by default, so you don't need to specify a start value if you want to start at 0. You can also specify a step value in the range function to skip over certain values. The syntax is range, start, end, step. For example, for I in range, 0, 10, 2. Print I. This code will print the even numbers 0 through 8 to the console. Lists in Python. In Python, a list is a collection of values that can be of any data type, including other lists. Lists in Python. In Python, a list is a collection of values that can be of any data type, including other lists. Lists are ordered and changeable, and allow you to store and access data efficiently. To create a list in Python, you use square brackets, and separate the items in the list with commas. Here's an example of creating a list. Fruits equals apple, banana, cherry. You can access items in a list using indexing. The index of the first item in the list is 0, the index of the second item is 1, and so on. Here's an example of accessing items in a list. Fruits equals apple, banana, cherry. Print fruits 0 hash output apple. Print fruits 1 hash output banana. Print fruits 2 hash output cherry. Tuples in Python. In Python, a tuple is a immutable sequence type, similar to a list. Tuples are ordered and can contain elements of different data types. To create a tuple in Python, you use parentheses, and separate the items in the tuple with commas. You can access items in a tuple using indexing, just like you would with a list. The index of the first item in the tuple is 0, the index of the second item is 1, and so on. Here's an example of accessing items in a tuple. T equals 1, 2, 3. Print T 0 hash output 1. Print T 1 hash output 2. Print T 2 hash output 3. You can also use slicing to access a range of items in the tuple. Slicing uses the syntax tuple start, end, where start is the index of the first item to include in the slice and end is the index of the item after the last item to include in the slice. For example, T equals 1, 2, 3, 4, 5. Print T 1 to 4 hash output 2, 3, 4. Dictionaries. In Python, a dictionary is a collection of key-value pairs. Dictionaries are unordered, changeable, and do not allow duplicate keys. To create a dictionary in Python, you use curly braces, and specify the key-value pairs using a colon, smiley face. Here's an example of creating a dictionary. Person equals name, John Smith. Age, 30. City, New York. Closing curly bracket. You can access the values in a dictionary using the keys. Here's an example of accessing values in a dictionary. Person equals name, John Smith. Age, 30. City, New York. Closing curly bracket. Print person name hash output John Smith. Print person age hash output 30. Print person city hash output New York. You can also use the get method to access values in a dictionary. This method returns the value for the specified key if it exists in the dictionary, and returns a default value if it does not. Functions
is a block of code that can be reused multiple times in a program. Functions help to organize and structure code, making it easier to understand and maintain. A function is defined using the def keyword, followed by the name of the function, and a set of parentheses. The parentheses can contain parameters, which are variables that can be passed into the function when it is called. The block of code that makes up the function is indented underneath the function definition. The function can return a value or result using the return keyword. Def example _ function, param1, param2. Hash function code here result equals param1 plus param2 return result equals example _ function, 5, 10. Print result. This example defines a function called example _ function that takes two parameters, param1 inch and param2 inches, and returns the result of adding them together. The function is called with the values 5 and 10, and the returned value is assigned to the variable result. Exceptions in Python. An exception is an event that occurs during the execution of a program that disrupts the normal flow of instructions. When an exception occurs, the program will terminate unless it is handled by code that catches the exception. Exceptions are raised, or thrown, using the raise keyword, and they can be caught and handled using a try except block. Try. Hash sum code here result equals 1/0 except 0 division error. Print, cannot divide by 0. In this example, the code inside the try block is executed. If an exception of type 0 division error is raised, the code inside the except block will be executed and will catch the exception. The program will continue to execute any code that comes after the except block. If you don't specify the type of exception, the except block will catch all the exception types. Try. Some code here result equals 1/0 except. Print, an error occurred. There's also a finally block which will always be executed after try except block whether the exception occurred or not. Try. Some code here result equals 1/0 except 0 division error. Print, cannot divide by 0. Finally. Print, this line will be executed always. Python has several built-in exception classes, such as zero division error, type error, and value error, that can be used to indicate specific types of errors. Developers can also create custom exception classes by creating a new class that inherits from the built-in exception class. Classes in Python. A class is a template for creating objects, a particular data structure, providing initial values for state, member variables or attributes, and implementations of behavior, member functions or methods. Classes are defined using the class keyword, followed by the name of the class. Here's a basic example of a class definition in Python. Class example class. Def__init__ self, attribute 1, attribute 2. Self. Attribute 1 equals attribute 1 self. Attribute 2 equals attribute 2 def example underscore method, self. Print. This is an example method. Example underscore object equals example class, 5, 10. Print, example underscore object. Attribute 1, #5 print, example underscore object. Attribute 2, #10 example underscore object. Example underscore method, #. In this example class is the name of the class. __init__ is a special method known as a constructor, which is used to initialize the attributes of the class when an object is created. Self is a reference to the instance of the class, it is the way an instance refers to itself. The example underscore method is a member function of the class. To call a method on an instance of the class, we use the dot notation like example underscore object. Example underscore method. In Python, class methods and attributes are by default public. Means they can be accessed and modified from anywhere, but Python also supports private methods and attributes by prefixing the variable name with double underscores. __private attribute makes the variable private. It will not be directly accessible but can be accessed using _class name _ private attribute syntax. Inheritance is a mechanism in object-oriented programming that allows a new class to be derived from an existing class. The new class, called a subclass or derived class, inherits the attributes and behavior of the existing class, called the superclass or base class. In Python, inheritance is implemented by creating a new class that inherits from an existing class using the class keyword, followed by the name of the new class, and a set of parentheses that contain the name of the class to inherit from. Class parent class. def underscore underscore init underscore underscore, self, attribute 1, attribute 2. Self. Attribute 1 equals attribute 1 self. Attribute 2 equals attribute 2 def example underscore method, self. Print. This is an example method from parent class. Class child class, parent class. Def underscore underscore init underscore underscore, self, attribute 1, attribute 2, attribute 3. Super, underscore underscore init underscore underscore, attribute 1, attribute 2. Self. Attribute 3 equals attribute 3 def example underscore method, self. Print. This is an example method from child class. Child underscore object equals child class, 5, 10, 15. Print, child underscore object. Attribute 1, hash 5 print, child underscore object. Attribute 2, hash 10 print, child underscore object. Attribute 3, hash 15 child underscore object. Example underscore method, hash. This is an example method from child class. Child underscore object. Example underscore method, hash. This is an example method from child class. In this example, child class is a new class that inherits from the existing parent class. Child class will have access to all attributes and methods of parent class, as well as any attributes and methods that are unique to the child class. Child class can also override the parent class method, which is called method overriding. Super function allows to call the methods from parent class. Inheritance allows for a more efficient and effective reuse of code, and it's a fundamental concept in object-oriented programming. Reuse of code, and it's a fundamental concept in object-oriented programming. When a class inherits from a superclass, it inherits all of the superclass's attributes and methods, and can add new attributes and methods or modify existing ones to fit its specific needs. Modules in Python. A module is a single file that contains Python code. It can define functions, classes, and variables, and can be imported into other Python scripts to use the functionality defined within it. Using modules helps to organize code and make it more reusable. A module can be created by saving a Python file with a py extension. The name of the file is the name of the module. For example, if you have a file named example_module.py, you can import it into another script using the import statement. Import example_module. Once a module is imported, you can access the functions, classes, and variables defined in the module using the dot notation. For example, import example_module result equals example_module, example_function, 5, 10. Print, result. You can also import specific elements from a module using the from keyword. Import example_module as x result equals x, example_function, 5, 10. Print, result. You can also use the as keyword to give an imported function, class or module a different name within the current scope. Import example_module as x result equals x, example_function, 5, 10. Print, result. You can also use dir function to see all the available functions, classes and variables in a module. Python comes with a lot of built-in modules and also have a large number of external libraries in the Python package index, PyPI, that you can download and use in your projects. Creating and using your own module is a great way to organize your code and make it more reusable. Packages in Python. A package is a collection of modules that are organized in a directory hierarchy. Packages allow you to organize your code into logical groups, making it easier to understand and maintain. A package is created by creating a directory with a specific name and then placing one or more py files inside it. The directory should contain a file called __init_.py that indicates that the directory should be considered a Python package. This file can be empty, or it can contain Python code. The package's modules can be imported into other Python scripts using the import statement, but the package's name must be included as well. For example, import package _name. Module _name. You can also use the from keyword to import specific elements from a package. From package _name, module _name import function _name. It's also possible to use relative imports. That allows to import modules from the same package without specifying package name from. Import module _name packages can also contain sub-packages, allowing for a deeper level of organization. This is done by creating a new package inside an existing package, the same way that a package is created inside a directory. Packages are an important tool for structuring and organizing large projects. They allow you to organize code in a hierarchical way, making it easier to understand and maintain. Also by providing a namespace to avoid naming collisions between modules and also make it easier to distribute your code to others. Python Standard Library. The Python Standard Library is a collection of modules that are included with Python when it is installed. These modules provide a wide variety of functionality, including functionality for working with numbers, strings, dates and times, files, and more. The Python Standard Library is organized into several sub-packages and modules. Some of the most widely used modules are Filled Circle OS and OS Path provides functionality for interacting with the operating system, including working with file and directory paths. Filled Circle SYS provides access to variables and functions related to the Python interpreter, such as the version of Python, command line arguments, and the current working directory. Filled Circle Math provides mathematical functions, such as trigonometric functions, logarithms, and basic arithmetic operations. Filled Circle Datetime provides classes for working with dates and times, including the datetime, date, time, and time delta classes. Filled Circle Random provides functions for generating random numbers and selecting random elements from a list or other data structure. Filled Circle provides regular expression pattern matching operations. Filled Circle JSON provides functions for working with JSON data, including the loads and dumps functions for parsing and serializing JSON data, respectively. Filled Circle lib provides functionalities for working with URLs, such as opening URLs, read and parse the data from them. Filled Circle Collections provides useful data structures such as counter to count elements in a list, ordered dict to have a ordered dictionary. This is just a small selection of the modules provided by the Python Standard Library. The full list of modules and their documentation can be found in the official Python documentation. These modules are widely used and well tested. They are a great resource for solving common programming problems. Python Package Index. The Python Package Index, PyPI, is a repository of Python packages that are made available for free to the Python community. It is a centralized package repository that makes it easy for developers to find, install, and distribute their own packages as well as packages created by other developers. PyPI is the default package index for the pip package manager, which is included with Python and is used to install and manage Python packages. Pip allows you to easily find and install packages from PyPI using the command line. For example, to install the requests package, you can use the following command. Pip install requests. PyPI also provide a web interface that allows you to search for packages, view package details, and download package source code. You can access it by visiting the HTTP URL. Pippy is maintained by the Python Software Foundation, a non-profit organization that supports the Python community. Pippy contains a wide variety of packages that cover a wide range of functionality, from scientific computing and data analysis to web development and machine learning. Many of these packages are maintained by the community, and new packages are being added to Pippy all the time. Packages in Pippy are usually written in Python, and some of the most popular packages include Filled Circle NumPy for numerical computations, Filled Circle Pandas for data manipulation and analysis, Filled Circle SciPy for scientific and technical computing, Filled Circle Matplotlib for data visualization, Filled Circle Scikit, Filled Circle Requests for interacting with HTTP servers, Filled Circle Flask and Django for web development, Filled Circle NLTK for natural language processing. Pippy makes it easy to find and use these packages, and also allows developers to easily share and distribute their own packages to the Python community. Thank you. I am so thankful for your patience and understanding. Your willingness to help and support me through this has been truly invaluable.